How to do pulley problems quickly and 100% accurate in 3 easy steps. These steps are: everything going with the acceleration is positive, consider gravity, friction, and any other forces on an inclined object, and generate an F equals to ma system for every other object. I'll show you exactly how to do this with this problem. We got a pulley problem with 8 marks asking, show that the tension is this, 12 mg over 5. First thing, get what your sine theta and cos theta is, because that will be necessary for the component on the inclined slope, as the weight is broken down into a gravity component and a perpendicular component, the reaction. So you got given tan theta is equal to this, and then you're supposed to create a triangle to find sine theta and cos theta. Next, take F equals to ma equation for the object suspended, with the acceleration assumed downwards. It doesn't matter which way you guess the acceleration, as long as you're consistent. The tension always acts away from the object, in this case upwards. So according to step number 1, tension is negative, the weight is positive, which is then equal to ma. Sum of forces is equal to ma. Focusing on the object on the inclined plane now, it was mentioned that it sits on a frictional surface. So because of that, you have a frictional force acting against acceleration, the gravitational component pushing the object downwards, and the tension acting on the system. For the friction, it is mu times the reaction, and reaction is 2 mg cos theta. The gravitational component is 2 mg sine theta. So now, take forces down the slope as negative, as they oppose the acceleration, and tension as positive, as it moves with the acceleration, giving you another tension equation as before. Now, you did step 3, which is to generate F equals ma for both objects. And in a problem where objects are connected, the tension is the same everywhere. So make the tension equal to each other, find the acceleration, and sub it into either of the equations to get your tension as 12 mg over 5. The next one states that object B will reach the floor, meaning that A will be under the effect of gravity, and we're being asked if it will stay still or go down the slope. This is really asking, is the friction greater than gravity component, as gravity will be the only thing that will act on it once the object stops moving. And after some calculations, you realize it is, meaning the block will stay there. Lastly, how to improve the model. Extensible string, include the mass of the string, add pulley friction, include air resistance, all the basic assumptions. Absolutely free marks every single time, as long as you follow the steps I showed.